distinși membri ai Academiei de Științe a Moldovei, stimați oaspeți, stimați cercetători științifici, profesori, studenți și prieteni ai științei, bună ziua! Astăzi, la Academia de Științe a Moldovei, trăim un moment de mare onoare și emoție. Suntem gazdele a două personalități de talie mondială, laureații Premiului Nobel, profesorii Hiroshi AMANO de la Universitatea Nagoya din Japonia și profesorul James ROTHMAN de la Universitatea Yale din Statele Unite ale Americii. Prezența lor la Chișinău este un eveniment istoric pentru Republica Moldova, dar și un mesaj puternic. Știința unește națiuni, creează punți între culturi și luminează drumul către un viitor sustenabil. Profesorul Hiroshi AMANO, laureat al Premiului Nobel pentru fizică în 2014, a transformat visul unei lumi mai luminoase în realitate. El a contribuit decisiv la inventarea diodelor electroluminescente albastre. Această inovație a permis apariția luminii albe eficiente și durabile, care astăzi luminează școli, case, spitale și orașe, reducând consumul de energie la un nivel global. Dincolo de tehnologie, realizarea lui Hiroshi AMANO a demonstrat că știința poate fi un far pentru dezvoltare și sustenabilitate. Profesorul Hiroshi AMANO ne va prezenta astăzi prelegerea sa intitulată "Să lucrăm împreună pentru a construi o lume sustenabilă". Este un mesaj esențial pentru timpul în care trăim, când omenirea caută soluții la crize de sănătate, provocări energetice și tehnologice, pentru un progres responsabil față de generațiile viitoare. În semn de recunoaștere pentru contribuțiile sale științifice și exemplul său inspirațional, precum și pentru o colaborare fructuoasă cu mediul academic din Republica Moldova, Academia de Științe a Moldovei i-a conferit profesorului Hiroshi AMANO titlul de membru de onoare și astăzi urmează să-i înmânăm distinsului savant însemnele respective. Profesorul James ROTHMAN, laureat al Premiului Nobel pentru medicină în 2013, a descoperit cum celulele comunică între ele, cum transportă și livrează cu precizie absolută substanțe vitale pentru hormoni, enzime sau neurotransmițători. El a identificat proteine care fac posibilă fuziunea veziculelor celulare cu țintele lor exacte. Această revelație a arătat cum funcționează poșta invizibilă a vieții, aducând înțelegere profundă pentru sănătate și boală. Astăzi avem bucuria și emoția de a-l cinsti pe profesorul James ROTHMAN prin acordarea Medaliei Dimitrie Cantemir, cea mai înaltă distincție a Academiei noastre. Pentru noi, această distincție are și o încărcătură simbolică aparte. Profesorul ROTHMAN are rădăcini genealogice basarabene. Străbunicii săi, emigrând din Fălești și Telenești în Statele Unite la începutul secolului al XX-lea. Prin vizita din această săptămână, dumnealui este primul reprezentant al familiei care revine la baștină după mai bine de 100 de ani. Acest fapt ne emoționează profund și dă evenimentului nostru o dimensiune istorică și sufletească aparte. Salutăm astăzi și prezența doamnei profesor Joy Hirsch de la Universitatea Yale din Statele Unite ale Americii, o personalitate notorie în domeniul biomedicinei, care vineri ne va prezenta prelegerea noua neuroștiință a celor doi, înțelegerea interacțiunilor sociale umane în lumea naturală de zi cu zi. Onorată asistență, întâlnirea noastră are loc într-un moment simbolic, chiar în zilele în care Academia Regală Suedeză de Științe anunță noii laureați ai Premiului Nobel. Astfel, Chișinău se află astăzi pe harta mondială a științei în dialog direct cu marile valori ale cunoașterii universale. Dragi invitați, elevi, studenți și tineri cercetători, acest eveniment este în primul rând pentru dumneavoastră. Prezența laureaților Nobel la Chișinău ne arată că prin muncă, pasiune și perseverență, știința poate transforma lumea, iar visurile de azi pot deveni realitate de mâine. Declar deschis acest eveniment de mare însemnătate pentru Academia de Științe a Moldovei și pentru societatea noastră. Să-i primim pe distinșii noștri oaspeți cu respectul și recunoștința cuvenită. Tradițional, la deschiderea conferințelor și a prelegerilor publice este interpretată compoziția Academia, simbol al națiunii. Vă rog, compoziția muzicală, autor, domnul profesor Constantin Rusnac. Trecem la realizarea agendei de astăzi. Noi avem o prelegere publică și întâlnirea domnului profesor Hiroshi AMANO cu comunitatea științifică și, în primul rând, cu tinerii Republicii Moldova, elevi, studenți, ei sunt în sală. Și vineri vom avea o întâlnire similară. Domnul profesor James ROTHMAN va avea o prelegere publică și, de asemenea, va avea o prelegere foarte interesantă doamna profesor Joy Hirsch, pe data de 10 octombrie, vineri. Începem realizarea programului. Dear Professor Hiroshi AMANO, you are the first speaker. Please. Și după prelegere va fi un moment așa festiv. Vom înmâna însemnele de membru de onoare al Academiei de Științe a Moldovei, domnul profesor Hiroshi AMANO, care deja de mai multe ori a fost împreună cu noi. Cei drept până acum în spațiu virtual, astăzi review. So please, you have the floor.
Okay. Thank you, Professor Tignano, for the kind introduction. Distinguished guests, ladies and gentlemen, especially the young students, it is my great honor to be here and give a talk in the blue room. So, first of all, I'd like to thank the Professor Tignano for giving me this opportunity to discuss the young students. Today, I'd like to explain our attitude to the young student. Let's work together to build a sustainable world. Okay. Yeah, there is a similarity between Moldova and Japan. Okay. I'm thinking what Japanese researchers can do for the people of Moldova. This is the carbon dioxide emission per capita. In Japan, the total carbon dioxide emission is much, much larger than the people in Moldova. It's 7.54 in Japan, and in Moldova it's 4.04. But in Japan, it is gradually decreasing, while in Moldova it increases drastically. And I also would like to mention that the role of semiconductor researchers are becoming larger and larger because the Republic of Moldova is importing almost 100% of fossil energy resources. Okay. About 70% of its electricity demands. So to transition towards a carbon neutral future, the Republic of Moldova should untap its renewable energy potential and invest in renewable energy infrastructure. The reason why I'd like to collaborate with you, especially the young leaders, is because of the development of power semiconductor devices. The power devices are used for every kind of electric systems. And if we say like a human, the silicon is like a brain of the human. So it memorizes or it can calculate. While the power devices provide electricity or power to all the system. So the power device is like a heart of the human. And I mentioned in the morning international conference that we need a very high efficiency, conversion efficiency devices. For example, if you operate your PC at home by the solar panel on the roof, the solar panel provides the DC power, but you use the AC power at home, and you have to transform the DC power to AC power, and then again you have to transfer the AC power to DC power, and then control the DC voltage. So in average, you have to transform in average 4 times. And if each conversion efficiency is 93%. It's an average of a conversion efficiency. The 4 times of the conversion leads to, in total, 75%. So about a quarter of electricity is lost in your system. That's why we are trying to develop much efficient system based on the new semiconductor materials, that is silicon carbide and gallium nitride. The reason why silicon carbide or gallium nitride is so promising is because this is the on-resistance means the loss as a function of breakdown voltage. Compared with the conventional silicon device, we can reduce the loss to at least 2 orders of magnitude by using a silicon carbide or gallium nitride. And even compared with the silicon carbide, we can reduce the loss to 1/10 by using the gallium nitride. That is why we are interested in the gallium nitride for power device applications. And this is the roadmap of realizing a net zero emission by 2050 in Japan. Now we are trying to develop an mobility zero emission by year 2030, and then digital inertial control system with smart power grid by gallium nitride. Okay? The reason is, if the renewable energy ratio increase, there are very serious problem of frequency modulation. I don't know. In Moldova, the frequency is 50 hertz or 60 hertz? 50, okay. If you use the 50 hertz frequency, and if you use the renewable energy, the frequency will change about 0.5 hertz, 49.5 hertz, and then every system blackout. So the control of the frequency is very, very important to increase the ratio of renewable energy. Yeah, this is the similarity between Moldova and Japan. In Japan, energy independence is only 12%, very low. So the Japanese people think we have to increase the renewable energy, especially the solar or wind. It is called the variable renewable energy, which means we have to save to the battery and then use it. Conventional system is motorized generation system, so we use the very big motors for electricity generation. So the frequency is very, very stable. But if you increase the ratio of renewable energy, the technology to stabilize the frequency is very, very difficult, and high technology is necessary. So that's why we need a fast frequency response system, fast frequency response inverters, and solid state transformer to connect to the electricity grids. gallium nitride is already used for your AC adapter of your computer, PC. So the AC adapter becomes smaller and smaller. The reason is you use the gallium nitride HEMT, high electron mobility transistor. But the gallium nitride HEMT, it is grown on silicon substrate, and the power is limited. For example, your AC adapter, the power is the 130 watt maximum. Okay? The reason is the power is limited by each transistor. There are many killer defects, so it is difficult to control much higher power. But for electric vehicle applications or the electricity grid application, we need a chip which can operate with much higher power or higher current. So we are trying to develop gallium nitride on gallium nitride material or substrate. So we can reduce the chip size by using a vertical. Now, the high electron mobility transistor, the carriers move horizontally, but if we can use the gallium nitride substrate, the carriers move vertically, by which we can reduce the size and we can increase the power for operation. But at present, almost all the people do not believe that gallium nitride power devices in the market. The reason is the cost is very high. It's more than 1,000 higher than that of silicon. And even compared with silicon carbide, it is more than 60 times higher. So we need to reduce the total fabrication cost to less than 1/10 times 1/10 times 1/10. So we have to reduce the cost to 3 orders of magnitude. I have the experience of the blue LEDs in the market. 10 years of the marketing, we can reduce the cost to 1/10. Okay? And also, we have the manufacturing technology for big gallium nitride bulls with a collaboration of Mitsubishi Chemical, Japan Steel Works, and Tohoku University. And we can grow this kind of bulk gallium nitride today. And also, we have a new technology of recycling the bulk gallium nitride. After growing the device structure, it was sliced from the bottom to irradiate laser just below the 50 microns, and then sliced the devices, and the remaining wafer can be recycled. And we already recycled more than 10 times. So we can expect a reduction of cost to 1/10. Our team is the comprehensive team for under one roof research and development team from crystal growth through the system application. Some people are concentrating on the growing bulk gallium nitride, and some people are developing electric vehicles in our campus. Okay. So we need young leaders, and we have the Japanese government support our young leaders cultivation program that is called the DII. It's a collaborative graduate program for accelerating innovation in future electronics. I don't know much about the educational system in Moldova, but in Japan, the graduation is 2 years for master's course and 3 years for doctoral course. So we combine these two, so it's a 5 years program. The reason why we need new educational system is this is the Nikkei stock average in logarithmic scale, and this is the major era. It started in 1868. It's a dome of a Japanese economy. It's an import of Western culture. And then first long-term slump, and then Japan was defeated in 1945. But after that, it's a big slope of the growth, second rapid period of rapid growth. And then it's an era of mass production. And we faced the peak in 1990s. Then we are now facing the second slump. So we believe, many Japanese people think that we need our own innovation. This is a survey on the status of university launch ventures. In some areas, for example, IT software or the bio or healthcare, the number of startup companies from universities increased drastically. However, the IT hardware or environmental technology or energy technology or chemical or materials, the growth rate is very, very slow. So to overcome such a situation, we are starting the new educational program for graduate students. We call it the DIA program. D stands for deployer, to create values in society, and innovator, to create products, technology, and investigator, to create technical seeds. Developing on the premise of collaborating 3 different types of students with different roles, we can realize the 30 years of innovation to less than 10 years. This is our 5 years the curriculum in School of Engineering. So it's a 5 years. And some student said that this curriculum gave me the confidence to do well, no matter where I go or what I do. And it's a unique point of our program. Mentors are not inside the university. All the mentors are outside the university. So industry people or National Research Institute people are joining our program and act as mentors. So the first year we are conducting the short-term overseas program in collaboration with the Singapore, the reactor schools. And the first year and the second year, we invited many famous people, not the engineers, but like astronauts or vice president of Google, or a startup company like Global Garage, US Embassy, or TV Tokyo casters. And in the School of Engineering, we add the entrepreneurship and market analysis using the real market data. And also, we are doing the experiments, which is not the specialist. For example, the School of Department Omae, she developed a startup company during her doctoral program. And she received the pitch contest Panasonic Award. And this team get the Campus Venture Grand Prix National Competition Ministry of Education Award. So, in such a way, many talented young leaders become the real researchers. And lastly, I'd like to explain one of the effects of the DIA program at company interview for job hunting. DIA graduate tried to get the job at Shiseido. Shiseido is a cosmetic company. Okay. He said, I had experience of startup company through DIA program, so I am high career level person, unlike other PhD graduates. So the interviewer said, okay, so your salary is double that of newly graduated PhD. This is very uncommon in Japan. All the people had the same salary. Yeah, their salaries were almost uniformly fixed, and there was no negotiation. But DIA graduates, our DIA graduates are breaking Japanese old conventions and lead to the new society, like a net zero emission society. So finally, young generation, please come to our university, Nagoya University, and let's work together to build a sustainable world. Thank you very much for your kind attention.
Yeah, thank you very much, Professor Amano. Noi am planificat ca după această prelegere să înmânăm domnului profesor Hiroshi AMANO însemnele de membru de onoare al Academiei de Științe a Moldovei. Decizia a fost luată de adunarea generală a Academiei de Științe și noi chiar îl așteptam pe domnul profesor să vină ca deci să primească aceste însemne. Cine la noi să vină, dar eu în primul rând So, Please come here. Certificate, honorary member of the Academy of Sciences of Moldova is conferred to Professor Hiroshi AMANO, Center for Integrated Research of Future Electronics, Nagoya University, Japan. So, dear Professor, come over here. So, this is the of the Academy of Sciences. Yeah. So, let me put it here. Yes, that's very good. Now, dear Professor, so we keep this one just to make a picture of history. Yes. Yeah, thank you. Now come here, because you see there were many questions. You see 3 pages of questions from students. Yeah, yes. Of course, I selected a few. Okay. So, yeah. Professor AMANO, what motivated you to come to such a small country as the Republic of Moldova to speak about such a complex discovery? Please.
Yeah, I think, I believe that there is a very, there is a similarity between Moldova and Japan, like energy scarcity or,
yeah,
so I think the collaboration with these two countries, we can solve the problems in future. Yes.
Deci, domnul profesor a spus așa că nici Japonia nu are surse energetice naturale, nici Moldova. Noi suntem în situații foarte similare și trebuie să colaborăm. Și eu cred că are perfectă dreptate. Did you ever feel like the task was impossible to achieve, and how did you overcome that? That the task was impossible to achieve, and how you overcome that? Actually, the elaboration of the PN junction and gallium nitride is just this case. Please.
Okay. At that time, I was very young, so I never thought that it is impossible.
You are still very young, so...
Yeah. When I started the research, I always believed that I can do that.
Okay, good. And dear Professor, how did you decide to pursue physics engineering? Because now people go to medicine, to other disciplines, but physics engineering, it's rather seldom, at least in Moldova. How did you decide to pursue physics engineering?
Oh, okay. My case, it's not so positive. When I was a high school student, I'd like to pursue the mathematics.
I see.
Yeah, but during the examination, the entrance examination, I failed. So that's why I choose the engineering.
I see.
Yeah.
Okay, good. And one more question.
Yeah.
What advice would you give to young students like us, those who are here, who are just starting to study biophysics? That means your advice to young generation. How they can be as successful as you are.
Oh, it depends on each student, I think. One of the most important or most interesting device is the available device to monitor the health of each person. Yeah, yeah. Especially in Japan, the average age becomes increasing and increasing. So many people become elder and elder. So in such a case, how to keep the health condition is very important. So I believe that the wearable monitoring system is very, very effective to monitor the condition of each person.
Thank you so much. So, we still have here. Ladies and gentlemen, we have as a guest today the Nobel laureate in medicine, Professor James ROTHMAN. Professor James ROTHMAN contributed to the success of the summer school this year. We are developing a close collaboration. I would here open the brackets. He visits us together with Professor Joy Hirsch. Professor is a well-known professor in the world, and at the same time is the wife of Professor James ROTHMAN. So Professor Hirsch will deliver a lecture on Friday, so we will have the possibility to attend that lecture. But today, there was a decision of the Presidium of the Academy of Sciences of Moldova, and I will just read here. Dimitrie Cantemir Medal is awarded to Professor James ROTHMAN, Yale University, United States of America, for the outstanding achievements in science, collaboration with the academic community of the Republic of Moldova, and for the contribution to the success of the international conferences and summer schools organized by the Academy of Sciences of Moldova. Decision of the Presidium of the Academy of Sciences of Moldova from 28th of August 2025. Professor ROTHMAN, please. Yeah. Traditionally here. Yeah. So first of all, I will give you this medal, Dimitrie Cantemir Medal, for you. Okay. Yeah, very nice, actually, very nice. And congratulations. And please, yeah, you keep one hand here, and we look. Yeah, you may say a few words if you like. If you like a few words.
I'm really deeply honored to receive this medal. It means a lot to me personally, and it's been my pleasure to be able to contribute in a small way to the Academy and the efforts that you are making. It's also personally deeply meaningful to me because, as you mentioned before in your introduction, my grandfather and my grandmother were born in this country when it was Bessarabia and immigrated to the United States in the early 20th century. And I'm certain that they would be very surprised and proud to see a grandson so honored in this manner by their home country. So, thank you very much.
Thank you, Professor. And I would like just to inform you, să vă informez că joi, Universitatea de Stat de Medicină și Farmacie Nicolae Testimițanu va onora pe domnul profesor cu titlul de doctor honoris causa al Universității. Domnul rector este aici și cine dorește joi la ora 14:30 va fi un eveniment frumos la Universitatea de Stat de Medicină și Farmacie. Iar vineri, la ora 14, în sala Azurie, domnul profesor va avea o prelegere în fața tinerilor și va urma o prelegere publică a doamnei profesor Joy Hirsch. Așa că o să avem 2 zile, întrevederi, întâlniri, prelegeri. Eu cred că o să fie așa un schimb bun de informații și create punți de colaborare cu domnul profesor și doamna profesor, cu atât mai mult că rădăcinile sunt basarabene. De aici a plecat. Pot să vă spun că deci, l-a cunoscut bine și au colaborat cu domnul profesor George Mil Palade, născut la Iași, care a emigrat în Statele Unite ale Americii, este considerat părintele biologiei celulare și când domnul profesor George Mil Palade a plecat în lumea celor drepți, în fruntea institutului a devenit domnul profesor James ROTHMAN, care cu timpul a devenit și dumnealui laureat al Premiului Nobel și vedeți, eu consider că oamenii noștri acolo deci, au reușit to make a breakthrough. Thank you so much. Deci noi mai avem timp. Dacă este vreo întrebare la domnul profesor astăzi, noi o să avem o întâlnire vineri. Dar dacă este vreo întrebare la domnul profesor, aveți posibilitatea să o formulați astăzi. Dacă nu, asta înseamnă că noi finalizăm evenimentul de astăzi, dar îl finalizăm tradițional. Noi facem fotografii de familie, fiindcă ele rămân în istoria și a țării și a Academiei de Științe. Da, și aici o să facem, pentru că astăzi afară, mă rog, plouă și aici toți vin și așa, știți, în jur facem câteva rânduri și o să facem fotografii de familie toți împreună. So, Professor, this is yours. And this is yours. Okay. So,